Hello everyone. In the previous videos, we have already started with the magnetic effect of current, where we have seen that how when a current carrying conductor, whether it is straight or it is in the form of a circular loop, produces magnetic field, and the value of magnetic field for a straight current carrying conductor as well as for a circular loop at different points we have discussed, and we have calculated, and we have derived the values by using Biout-Savitz's law. Now here what we are going to discuss in this video is how we are going to determine the direction of magnetic field at the center of a circular current carrying loop. So you will be given a current carrying loop in the shape of a circle, and the magnetic field at the center, we have already derived the relation for the magnitude, so we will discuss the direction now. So let us see how it can be done. Here you will find two rules which we are going to discuss here in this video. The first rule is right hand thumb rule. It is used in a bit different way. We need to understand it very clearly. This rule says if we curl the palm of our right hand around the circular wire with the fingers pointing in the direction of current, then the extended thumb gives the direction of magnetic field. It means you can see my right hand. If I consider the curved fingers of my hand in such a way that they show the direction of current, then the thumb here will show the direction of magnetic field. Okay, I hope this is very clear to you. The direction of current in the circular loop is given by the curl of the fingers of your right hand. Then the thumb will give you the direction of magnetic field. Let me demonstrate it to you with the help of some figures. See, here you can see a circular current carrying loop shown by red arrows, which shows the current actually. So the direction of current, you can see here, it is in the clockwise direction, and if we take our right hand and if we curve the fingers in such a way that the direction of the current matches with the direction of the curve of our fingers of the right hand, then the thumb will represent the direction of magnetic field. And here you can see the magnetic field at the center will be in the inward direction. You can just try it yourself. You will find that if you curve your fingers in such a way that it matches with the direction of current, then the thumb will give you the direction of magnetic field at the center. Now let us take another example. Look at the direction of current now. We have taken it to be in the anti-clockwise direction, and in this direction, if you want to curve your fingers such that it matches with the direction of the current, then the thumb will be in the outward direction, which will give the direction of magnetic field at the center. Like this, if you consider the thumb in this way, that the curved fingers represent the direction of the current, then the thumb will give you the direction of magnetic field, which will be here in the outward direction. So accordingly, we have taken two examples here where we have seen that by taking the direction of curvature of our fingers in the right hand in the direction of the current, we can find the direction of magnetic field at the center of the circular current carrying loop. Now let me discuss one more thing here. Let me show you something. Suppose I take a bar magnet. Sometime or the other you must have always seen a magnet. Now a magnet which is in the form of a bar, you have studied in class 10th also, I suppose. I am drawing a bar magnet here. You can see here this bar magnet. One end will be the North Pole and another end will be the South Pole, right? Now, the magnetic lines of force will be from the North Pole to the South Pole outside the magnet, okay? But inside the magnet, it enters from the South Pole and leaves from the North Pole. That is, inside the magnet, the direction is actually from south to north. So you need to understand that if we are just considering a magnet, then from the South Pole of the magnetic lines of force will enter, and from the North Pole it will leave, which shows the direction of magnetic field at the South and the North Pole. Further, one more thing you can see here, that the magnetic lines of force are continuous in nature. That is, they don't have the starting point, they don't have the ending point. What we can say is, for the North Pole, it moves away out of the North Pole, and from the South Pole it enters the magnet. Okay, so I hope this is clear. So on the basis of this, we will discuss the second way in which we can determine the direction. So let us see that. Okay. Now the next rule which we are going to discuss here, it is popularly known as clock rule, and it's a very, very simple rule. And whatever we have discussed in the first rule, that is the right hand thumb rule, it is almost analogous, but we will interpret it in a little bit different way. This rule gives the priority of any phase of a circular current loop. If the current round any phase of the coil is in anti-clockwise direction, it behaves like a North Pole. If the current flows in the clockwise direction, it behaves as a South Pole. Okay, so that you need to remember. That is, if you see that the current is in the clockwise direction, it will behave as a South Pole. If the current is in the anti-clockwise direction, it will behave as a North Pole. So let us see how it can be considered. Again, we take the same example, but we will interpret it in a bit different way. See, here you can see the direction of current. It is in the anti-clockwise direction. Now, if it is in the anti-clockwise direction, we all know, if we use the first rule here, that we take the curved fingers, then the magnetic field will be in the outward direction. Now, just now, before this, we have just discussed that when we take a bar magnet, magnetic lines will come out of the North Pole. Okay, so if it is coming out from the center, that means this phase will behave as a North Pole. Okay, so it is in the anti-clockwise direction, it behaves as a North Pole. Let us take the example of the another phase. Look at this phase. This is a clockwise direction. In this clockwise direction, if you take the first rule, that is the right hand thumb rule, where we take the direction of fingers in the direction of current, then you will find that at the center the thumb is in the inward direction. That inward direction shows that the magnetic lines are entering into this phase. So this phase of the current loop will behave as a South Pole, because we know, we have seen it in the bar magnet, that the current magnetic lines enters from the South Pole. So if the direction of current is clockwise, then it behaves as a South Pole. So this thing can again be made clear by example which I am going to show you now. I am widening the screen so that I can show you something. Look here. I have drawn it in a page in which you can see here the direction of current. It's in the clockwise direction. You can see here it is in the clockwise direction. So if it is in the clockwise direction, I will hold my curve fingers like this, so that the thumb is in the inward direction. If the thumb is in the inward direction, that means magnetic lines are entering from here. So this phase will behave as the south pole of the current loop, that is the south pole of the magnet. This current loop is behaving as a magnet, and this is the south pole of the magnet. Now if I just turn the page and I am taking the trace of whatever I have drawn it here, you can see here from this side, this was the side which I have shown it to you. Now I am reversing the side. Now this same thing from this side will appear in the anti-clockwise direction. You can see the direction has now become anti-clockwise. Okay, so if the direction is anti-clockwise, that means we take our right hand in such a way that the curved fingers are in the direction of current, then the thumb is in the outward direction. So this phase represents the north pole of the magnet, because this is the north pole, because the magnetic lines are coming out of it. So a circular loop where the direction of current from your side, from which you see, if the direction of current is anti-clockwise, this behaves as the north pole. If the direction of current is clockwise, then it behaves as a south pole. I think it is very clear to you. Now, if it is clear, then let me show you the two things together. Here you see, we have taken the two opposite sides and shown it in the same page, where the north pole of the magnet, which is a current loop, you can see here, if the direction of current is in the anti-clockwise direction, it behaves as a north pole, whereas if it is in the direction of if the direction of current is clockwise, it behaves as a south pole. So I hope this thing is very clear to you. Any doubt, any kind of discussion you want, you can post me the doubts. Thank you.